In discussing telescopes, it would be a problem not to actually also discuss observatories, which is where you put telescopes, because you need to put an observatory in the right spot. And so that's where we run into some issues sometimes. For example, we know that the atmospheric windows, we talked about this before, atmospheric windows, the regions of the particular wavelengths that make it down to the ground. And we say we have the optical window, we get the radio windows, we have radio observatories, we get optical observatories, but we also know about atmospheric extinction, atmospheric absorption, and then atmospheric distortion. So you want to put your observatory where the air is cleared, so not where there's a lot of humidity. You don't want to put it near the coast. You don't want to put it at low elevations. Higher elevations, you tend to have clearer air. The other thing is you want to put it in the right spot so that as the wind goes past, it doesn't make it cloudy. That means if you put your observatory on the leeward side or the windward side of a mountain or a hill, that actually changes the weather conditions a little bit. The other thing is that we have the infrared window. The infrared light makes it almost to the ground, but not all the way. And so that means infrared telescope would not do well down the valley, but it would do much better at the top of a mountain. And so that's why a great many observatories are built on top of mountains. It gives you clear air. There's fewer people around, so there's less light pollution. The air is more steady, so there's less atmospheric distortion of what you're looking at. And you get more infrared light. And since that's a huge part of the electromagnetic spectrum, then you're missing out on a whole lot of that if you don't have that kind of opportunity to measure the infrared light. There are also a lot of things out there that give off more infrared light than they do even visual light. And so again, this is why you want to put your observatory on the top of a mountain if possible, on top of a mountain in a remote area, particularly a remote area that's dry. Because most North American telescopes or American telescopes are based in the United States in the Northern Hemisphere, National Science Foundation also wants to be able to have astronomers look at Southern Hemisphere targets because some of these things are very cool that can only be visible from the Southern Hemisphere, and some nearby galaxies that we want to study are visible from the Southern Hemisphere. So the National Science Foundation actually operates the Cerro Observatory in Chile, where we can see southern objects from this location. Again, it's on a mountaintop, where up in the mountains you have clear air and very dry air and very stable air. Near Tucson, Arizona is actually the Kitt Peak National Observatory, which is a set of telescopes here that are definitely some of the better ones in North America, including several that are specific for specific sort of applications, such as a solar telescope. The McMass Solar Telescope is designed so the sun image of the sun would hit a mirror here and then be projected down to a viewing room underground down here. We'll talk more about solar telescopes later. Another premier solar observatory, one that's actually a little more commonly utilized and is actually used a lot more than the previous one, is the Dunn Solar Telescope. It's actually located at the National Solar Observatory, an entire observatory just dedicated to studying the sun. It's near Alamogordo, New Mexico. So up in the mountains, a place that has actually a U.S. Post Office called Sunspot, New Mexico. And so that's where they have this National Solar Observatory, underground down there. The Mauna Kea Observatory, in which we have multiple telescopes here. It's an international organization. The Mauna Kea Observatory is obviously American because it's in Hawaii, but you have other countries that are putting things here because the sky is absolutely pristine and clear. It's one of the best places on Earth to build a telescope. And it's cold up there. The air is so thin, even though it's in Hawaii, it's cold. Yes, this is snow down here. You don't normally think of Hawaii as having snow. So if you're on your way to Hawaii and somebody, on the airplane is carrying a parka with them, then he or she may be going to the top of the mountain here, to the observatory. There are other telescopes that are here. Japan actually has a telescope they call the Subaru Telescope located here, and it is a coup de focus, so the light comes in, bounces up here, comes down here, then comes out the side, so the entire telescope pivots, but this area where the instruments are doesn't move, and so that way you can have several thousand-pound instruments. And as I've already mentioned, Texas has its own observatory, not just one. There's actually several observatories across Texas. The biggest one is actually operated by the University of Texas at Austin. It's called McDonald Observatory, and it's located in far west Texas in the Davis Mountains. There's not really anything particularly near there. Fort Davis is the closest town, and there's not really much there. But this is actually standing here at the Visitor Center looking up at one of the big telescopes there. McDonald Observatory, interestingly enough, was formed when a wealthy man by the name of McDonald gave the University of Texas money to build an observatory. And he gave them a bunch of money, and they said, well, sure, we'll build an observatory for you. Except that at the time, they did not even have any astronomers on staff. And so they ended up building a telescope, and that was the first one. And then they hired astronomers, created an astronomy department, and then they built what at the time was temporarily the largest telescope in North America. And then bigger telescopes got built elsewhere. There's a variety of smaller telescopes that are here on top of the mountain. There's living quarters here where astronomers can actually stay during the day and sleep all day and then work at night. So if they have to come from elsewhere to do observations. So this is the University of Texas McDonald Observatory located in far west Texas. And a number of years ago, I think I may have already seen this, show the slide, the Astronomy Club actually did a visit out there, and this is on the road leading up to the observatory right up there. That's the main observatory right there. When they got ready to build the Hobby-Eberly telescope, they had to build it on a different mountain because Mount Locke, the original mountain, was already full.